Hey everybody, welcome back to Chapter 8, Section 4. I'm doing a few more examples of adding and subtracting rational expressions. These will all have unlike denominators, and they'll be a bit more complex than what we did in Part 1. So with that being said, let's go ahead and get started. This first example here, I have 7 over 9x squared plus x over 3x squared. So what you'll want to do is you'll want to try and factor the bottom, or the denominators, I should say. Alright, so 9x squared, there's a variety of different ways you could rewrite 9x squared. You could write 9 times x squared, you could write 3 times 3x squared, 3x times 3x, and, there's a lot of different ways. So let's turn our attention to this, 3x squared plus 3x. They both clearly have a 3x in common. So I'm going to factor that out. Remember, factoring is like dividing. So I'm going to divide 3x squared by 3x. Well, the 3's would cancel, and then x squared divided by x is just x. And then 3x divided by 3x is 1. Anything divided by itself is going to be 1. So I'll have x plus 1 in the parentheses. So now I just need to figure out, does 3x go into 9x squared, or does x plus 1 go into 9x squared? Well, what makes more sense? The 3x, right? What is 9x squared divided by 3x? Well, 9 divided by 3 is 3, right? So x squared divided by x is x. So 9x squared can be rewritten as 3x times 3x. And so the nice thing about that is they both have a 3x in common. Okay? So we're going to try and find the least common denominator. But so this one has two 3x's. This one only has one. So that means I'll have to add in a 3x on that one. And then this one has an x plus 1 that this one doesn't have. So that means this fraction will have to add in an x plus 1. So let's take a look at what that's going to look like. Okay, so in black I just rewrote our original fractions just with the denominators in factored form. And so, like I said before, this fraction had an x plus 1, so this fraction needs that x plus 1. You're always looking at what the other one has to try and give it to the other one. That sounds kind of confusing, but hope that makes sense. So this one has an x plus 1, so this one needs it. So what you do to the bottom, you must do to the top. Remember, you have to write the exact same thing over itself. So that way it's technically making a 1. Anything divided by itself is 1. So x plus 1 divided by x plus 1 is 1. And so if you multiply anything times 1, you're not changing the value of it. Anything times 1 is itself. Okay? So that's why I did x plus 1 times x plus 1 here. And then this one had two 3x's. This one only had one 3x. So I introduced a 3x over a 3x on that one. Okay? So basically, the next step is to just distribute the tops. Alright? And the bottoms, I'm just going to turn this 3x times 3x, these right here, back into 9x squared. And so I'll have 7 times x, that's 7x. 7 times 1, that's 7. Plus x times 3x is 3x squared. And so what I like to do is, rather than having to rewrite it again, 3x squared, that's a higher degree. That's going to need to go out in front of my 7x plus 7. So 3x squared, and since it was positive, I'll write plus. And so like I said before, that 3x times 3x, I'm just going to convert back to 9x squared. And then it'll say times x plus 1. Okay? So this problem's actually done right now, except I have not yet identified where x can equal. Remember, anytime there's x on the bottom of a fraction, it's going to restrict your domain somehow, because you cannot divide by 0. So there's two answers here. What are the two answers, or two values that x cannot equal? And if you think about it, if I plug in a 0 here, that's going to say 9 times 0 squared, which will just make 0. So that'll make the whole bottom go to 0. So we're going to say that x cannot equal 0. And then we're going to say that x cannot equal -1 as well, because -1 plus 1 would make this go to 0, and so that would make the whole bottom go to 0. So that is officially the final answer to this first example right there. This next example, I have a subtracting example. And so here I have x plus 2 over 2x minus 2. So immediately I see that that denominator can be rewritten as 2 times x minus 1. How did I know that? Well, they both have a 2 in common. So just factor out a 2. So 2x divided by 2 is x. 2 divided by 2 is 1. So yeah, that's how it became 2 times x minus 1. And then this bottom, well, if you have 3 terms, that means you're going to need to think, what are the factors of the last number, 3, that add up to the middle number of -4? So factors, put a dot for times, and then plus for add. Let's see here. 3 is 3 times 1. But 3 plus 1 adds up to 4, but it needs to be -4. So let's make these both negative. So therefore, I'm going to rewrite x squared minus 4x as x minus 3 times x minus 1. So let me just rewrite our fraction right now. Okay, so I went ahead and rewrote it in blue here with our factored denominators, I should say. So let's look at what we have here. This is 2 times x minus 1. This one also has an x minus 1. It just doesn't have a 2 in front. So we can make it have a 2 in front if you just multiply it by a 2 over 2. And that looks kind of crammed, so I'm going to erase that, and I'll just put it on the other side. So times 2 over 2. And so this other fraction here, has an x minus 3 that this one does not have. So I need this one to have an x minus 3. So I'll go over here, and I'll multiply an x minus 3 over an x minus 3. Alright? And so all we need to do now is just distribute our tops and take it from there. So let's do x times x, that's going to be x squared. And then we'll do x times -3, that's going to be -3x. Then we have 2 times x, so that's positive 2x. 2 times -3, that's -6. And so this one's kind of tricky here because we're going to do 2 times -1 and 2 times -2. So that's going to be, let's do 2 times -2x first, -4x. And 2 times -1 is -2. And then remember, there was a minus sign in the middle of all of this. So technically, you have minus this whole top part of the fraction still. So just put it in parentheses because we're going to have to distribute that negative, which will just flip those signs. So plus 4x plus 2. It's a small detail, but it's very important because if you don't do that, then you won't remember to distribute your negative, and then you end up getting the wrong answer even though you've done almost everything correctly. You just made that one mistake. So let's go ahead and combine like terms. So I have x squared, that can't combine with anything. So I'm just going to write that down. I have -3x plus 2x plus 4x. So that'll make plus 3x. And then I have -6 plus 2. So that'll make -4. And so here I have all this written over 2 times x minus 1 times x minus 3. Alright, there's a little bit more to this problem, but right now let's identify what x can't equal. We have x minus 1 and x minus 3, so just flip those signs. This 2 is not going to affect where x can't equal because there's no x with it. So x will not be able to equal, this is a comma, still doesn't look like a comma. X cannot equal 1 or 3. Okay? Now, this top, it made three terms again, right? So you want to check to see if you can factor that top. Um, I think the previous one made three terms, but that one couldn't factor. Usually when we give you something that's going to factor again, we won't put a number in front of the x squared because that'll just take forever. But x squared plus 3x minus 4, that can factor. What are your factors of negative 4 that add up to positive 3? And that's, well, 4 is 4 times 1. And if 4 is positive and 1 is negative, they'll add for a positive 3 and multiply for a negative 4. So I'm going to rewrite this top as, or the numerator, I keep saying top, x plus 4 times x minus 1, and that's over 2 times x minus 1 times x minus 3. So look, we have x minus 1s that will cancel. So it's just something to keep an eye out for at the end of your problem. See if you can factor it one more time. I'm sure by the time you get to the problem, you're wanting it to just be over. But yeah, check for it to factor down one more time because it just might. And so it's x plus 4 over 2 times x minus 3, where x cannot equal 1 or 3. Okay? So yeah, kind of a long example there, but I did warn you at the beginning of the video that these were a bit more complex. So let's do one more example. Here I have three terms, and they all have different denominators. But when you factor them down, you'll see they all have something in common. X squared plus 2x, they both have an x in common, so factor out that x. So x plus 2 will be left behind. And see, this one has an x plus 2, and you can't factor that at all. And then this one's x squared minus 3x, so I can factor out an x again, and that'll make x minus 3. So at this point, I'm going to rewrite these, but I'm going to put some gaps in between each fraction because I'm going to add something to each fraction. Okay, so let's look at what we have. We have x times x plus 2. So this one has an x plus 2, but not an x. So I'm going to add in, or multiply in, an x over x to this fraction. Now this fraction has the x on the outside, like the other two have, only it has an x minus 3 and not an x plus 2. So it needs the x plus 2. So I'm going to multiply an x plus 2 over an x plus 2 on this fraction. So now I have x times x plus 2, x times x plus 2, and then x times x minus 3 times x plus 2. So these other two fractions need this x minus 3 as well. So now if you look at it, they all have an x plus 2, and an x minus 3 in all the denominators. Each three terms each three fractions has three things in the same three things in the denominator. So we can keep our denominator the same like this, but we do need to distribute everything in the numerators. So let's start with the 5. We have 5 times x minus 3, so that'll make 5x minus 15. Then we're going to move to the 3 times x. So let's just group these together and treat it as a 3x, right? Because that's really what it is. So we have 3x times x, so that's 3x squared. And then we have 3x times negative 3, so that'll make negative 9x. And then I'm going to group this negative with the 4 and say, what's negative 4 times x? That's negative 4x. And then what's negative 4 times positive 2? And that's going to be negative 8. So here's everything written out. We just need to write it in order and combine like terms. 3x squared is the highest degree, so 3x squared. Minus 9x combines with minus 4x, combines with positive 5x. So that'll make negative 8x. And then I'm going to combine negative 15 with negative 8, and that'll make negative 23. And all that's going to be over x times x plus 2 times x minus 3, and we just need to identify what x can't equal. X cannot equal 0, -2, and +3. Because if you've plugged in a 0 here, that'd multiply everything times 0, making the bottom go to 0. If I plugged in a -2 here, that'd make the whole bottom go to 0. And if I plugged in a +3 here, that'd make the whole bottom go to 0. So now we are finally done with this problem. It can't factor anymore. And so thanks for watching the video. I know there were only 3 examples. It was kind of lengthy, so thanks for watching the whole thing. And goodbye.